Okay, time for example 2. Again, almost similar circuit except an extra voltage source at the top. By the way, the fact that it has a negative voltage difference has really nothing to do with it. I just wanted to show you an example that voltage and current sources can have negative values. Okay, now let's analyze this circuit. Step 1, identify all the nodes. How many nodes do you think this circuit has? If you thought 3 nodes, you would be wrong. This circuit has 4 nodes. Usually, everyone misses that tiny node on the top. That tiny piece of wire connects the 10 ohm resistor with the negative 3 volt voltage source. And any continuous piece of wire that connects 2 or more elements is a node. So take care when identifying the nodes. Also, let's label all the nodes, and again, let's not bother with the ground node. Step 2, write the equations for the voltage sources. We have 2 voltage sources in this circuit. Let's write equations for them one at a time. The bottom left voltage source has V1 voltage on the positive terminal and 0 volt on the negative terminal. So we have V1 equals 1.5. So we already solved one of the nodes again. Now let's write equation for the other voltage source. Given the positive terminal voltage being V2 and the negative terminal being V3, we have V2 minus V3 equals negative 3. Don't get panicked because it's a negative voltage. Just treat it as you usually do. Positive terminal voltage minus negative terminal voltage equal to the labeled voltage difference. Now notice, unlike the case of V1, we don't immediately get the values of V2 and V3. We could solve V1 because we knew the voltage on the other side was 0 volts. But here we don't know what's the value of either V2 or V3 at a glance. So this equation is the node equation for both node 2 and node 3 at the same time. As a heads up, since we don't get separate equations for node 2 and node 3, we call this a supernode. So this is a supernode equation. Okay, so we're done with the voltage sources, so it's time to move on to step 3. But before that, let's discuss the shortcut that I keep talking about. In the previous example, I asked you if you could find a pattern. Let's take a closer look at that. How can we write this equation for node 2 directly? Well, this part obviously comes from the current entering or exiting that node. And every term of these parts are also currents. These numbers, that is those tens and fours, are coming from resistance, and voltage divided by resistance is current. Of course, each of the terms should be current because you cannot add different units of things. So how is this voltage divided by resistance part constructed? First, notice we are writing equation for node 2 and the first term is V2. There are also other node voltages like V1 and node 0, but both of them have negative signs in front of them, but not V2. So your first clue is that all the node voltages have negative signs in front of them except V2, whose equation we are currently writing. V2 is the VIP here. Then we have these 1 by 10 and 1 by 4. This obviously comes from the resistances. So the 10 ohm and 4 ohm resistances are why we get 1 by 10 and 1 by 4. The only resistances attached to node 2 are these two. Also, on one end of the 10 ohm resistors, we have V2 itself, and on the other end, we have V1. And if you notice, we have V1 divided by 10 as well. Same thing for ground node and 4 ohm resistor. And then we have the normal current sources. So you can see where this pattern is coming from, right? Okay, so let's try to write this node equation for node 2 from scratch. First, we have V2 because we are working with node 2. Then V2 times inverse of all the resistors connected to node 2. namely 10 ohm and 4 ohm resistors. Now take each of the resistors and see what's the voltage on the other end of that resistor. For example, 10 ohm resistor has V1 on the other side. That's why we have negative V1 by 10. Remember, negative sign in front of all the nodes except the VIP V2. Next, the 4 ohm resistor has 0 volt on the other side, so we have negative 0 by 4 as the next term. And finally, we have 2 ampere current exiting the node and 0.5 amperes of current entering the node. So that's our final equation for node 2. With some practice, you can fluently write the equation and skip step 3 entirely. So, okay, back to example 2. Here, we will try to write node equations for node 2 and node 3. But that voltage source at the top will cause us trouble again because we don't know the current. So for now, let's say the current is I, following the passive sign convention, of course. Let's start with node 3. We are working with node 3, so that's the VIP. So start with the V3 times the inverse of all the resistors attached to it. Here we only have a 4 ohm resistor. So we write 1 by 4. Next, for each resistor, we have to write the terms for other end of those resistors. Here we have 0 volt on the other side of the 4 ohm resistor, so we write negative 0 by 4. Again, only the VIP gets to be positive and all other nodes are going to be negative. And lastly, we have 2 amperes exiting the node and 0.5 and I current entering the node. So we subtract 0.5 and I to get the full equation. And we didn't even have to bother with step 3. So let's try it one more time with node 2. This time I won't block the irrelevant parts. See if you can still figure out without the animations. Since we are working with node 2, first we write V2 times inverse of all the resistors attached to node 2. We only have 10 ohm here, so we write 1 by 10. Next, we have to write terms for the other sides of the resistor. 10 ohm resistor has a V1 voltage on the other side, so we write minus V1 by 10. Negative for non-VIP nodes. And lastly, we have a current I exiting the node, so we add that. Hopefully you can see how we get these node equations. Now there's still a small issue. We have an I in these equations, but we wanted to get everything purely in terms of node voltages. We can still do that if we just add up the node equations for node 2 and node 3, and the I's will just cancel. And we are left with this equation. This is also a mix of node 2 and node 3. Just look at who is the VIP of this equation. Both V2 and V3 have positive signs in front of them, so both of them are VIPs. In a nutshell, in this example, node 2 and node 3 are always associated with one another. So we call this a supernode that contains node 2 and node 3. The way you write a supernode equation is that you just ignore the voltage source that's causing the problem and write the node equations for the nodes. Now, you might be wondering, how do I understand when I need supernodes? This usually happens because of these voltage sources whose terminal voltages we don't know. For example, the 1.5 volt voltage source didn't cause any problem because we knew the terminal voltages of that voltage source, 1.5 and 0. But for this negative 3 volt voltage source, we didn't know what's the value of V2 or V3. That's what caused the problem. And no, the value negative 3 has really nothing to do with it. If the value was, say, 5 volts, it would still require a supernode. It's the position of the voltage source that is causing the problem. And now you have successfully reached up to this point. You have 3 variables, V1, V2, V3, and you have 3 equations. So you can use a calculator to find solution for them. And again, once we know all the node voltages, we can basically ask any questions and answer that. So we're basically done here. Hopefully it was clear and straightforward enough to demonstrate how nodal analysis is done. These steps will work on any circuit and done correctly will give you the correct answers. But if you write wrong equations, you will get totally different answers. So take care when you are writing node equations and also identifying nodes. I have provided some more examples for you, so you can go through those to get a better understanding of the nodal analysis method. You will have to tackle nodal analysis on the final exam, so learn them well. To aid you with that, I have 2 assignments on nodal analysis. So please try to complete them by yourself and before the exam, and that will definitely give you an advantage in the exam. You can still submit those assignments after the exam, but I think that won't really help you that much. If you are still not confident enough and want to practice some more, a practice sheet will be attached. So feel free to try out those as well. And if you have any questions, I'll be happy to tackle them. Thank you.